Okay, this is lesson 11.4. Hopefully, properties of two-dimensional figures. We're going to use problem solving with this today. How can you use the strategy act it out to approximate whether the sides of a figure are congruent? Lori has a quadrilateral with vertices A, B, C, and D. Remember, quadrilateral is where the two line segments meet. Vertices is where the two line segments meet. A quadrilateral has 4 right angles. She wants to show the quadrilateral ABCD is a square. Without a ruler, how can she show the quadrilateral has 4 congruent sides and is a square? What do I need to find? I need to determine whether the quadrilateral has 4 what? What's our math word? Congruent sides and is a square. Please write congruent and square in there. So quadrilateral has 4 congruent sides and it is a square. That's what we're trying to prove. What information do I need to use? This is straight down on your paper. What information do I need to use? The quadrilateral has what angles? 4 what kind of angles? Right angles. To be a square, it must also have what? 4 congruent sides. They have to be congruent. If they're not congruent, it's not a square. Okay. How will I use the information? I can trace the figure, cut it out, and then fold it to match each pair of sides to show that sides. Here's our little square. So we're going to fold it to show that sides AB. And we're going to write it like this. AB, comma. What side is that going to match? DC, comma, BC, and AD are congruent. So that side AB, DC, AD, and BC are congruent. So I traced a quadrilateral and I cut it out. I use acted out by folding to match each pair of sides. I fold the quadrilateral to match sides AB and CD. Okay, so if you're at home watching this, you need to get a piece of paper, cut yourself out a square, and label it like the one they show at the top of that page 435. So I fold the quadrilateral to match AD and BC. Are AD and BC the same? Yes. Then I fold the quadrilateral to match diagonally CD to BC. Are each of these the same?
Yes.
Yes. What else do you need to solve this problem? need to show that sides BC and AD are congruent, and that sides CD and AD are congruent by folding it along the other diagonal. So if you fold it like this, and again, if you're at home, you need to have a triangle or a square, and you need to be trying these things. So, quadrilateral ABCD, what? Is it a square or not?
Yes.
Is a square. Terrence has drawn a with vertices E, F, and G. The triangle has 3 congruent angles. He wants to show that triangle EFG has 3 congruent sides. Without a ruler, how can you show the triangle has 3 congruent sides? What do I need to find? I need to determine whether sides EF, FG, and GE have the same length. Again, I need to determine whether sides EF, FG, and GE have the same length. If you're watching at home, you may need to go ahead and stop that so that you get that. What information do I need to use? The figure is a triangle with 3 congruent angles. The figure is a triangle with the 3 congruent angles. Whoops. How will I use this information? I will trace the figure, cut it out, and then act it out by folding the figure to match all the sides to see if they are congruent. Okay. They don't give you number 2. I'm going to go back, add a page. Number 2 at the bottom of page 454 says, how can you use reasoning to show that all 3 sides of the triangle are congruent? Using just 2 folds. So how can you use reasoning to show that all 3 sides of the triangle are congruent? Using just 2 folds. Since 2 pair of sides of the triangle are congruent, the third pair are congruent since they have related sides. For example, since EF is congruent to FG and EF is congruent to EG, both FG and EG are congruent.